Hey everyone, welcome back to the Java for Beginners playlist here on GNT Creator channel. If you're new, my name is Mikita and I'm really glad you're here. In our first video, we've set up Java, IntelliJ IDEA, explored the basics of Java and got familiar with what this powerful programming language can do. Today, in the second video, we're going to dive a little deeper and start writing Java programs. We'll cover important concepts like variables and data types, and I'll show you exactly how to practice them step by step. By the end of this video, you'll feel more confident typing your own code and seeing it come to life on your screen. So grab your computer, open your IDE, and let's continue our journey into Java programming, one step at a time. Alright, so let's start from the first part, which is understanding variables in Java. So what is a variable? The word variable comes from the root word vary, which means something that can change. In programming, a variable is a named storage location in memory that can hold data and change its value during the execution of a program. So basically, variable is something that can vary or change. A variable is like a container in your computer's memory that stores data. Think of it as a labeled box where you can put values like numbers, text, or true-false condition. And here's an example. Imagine a box labeled age. You can put the number 31 in it. Later, you can check the box or even change the value. So why do we need variables? Variables allow us to store information, like a username or score in a game, for example. They allow us to reuse values without typing them again, perform calculations using stored data. Without variables, programming would be repetitive and chaotic. So what is a variable declaration? Variable declaration is the process of telling Java that you want to create a variable, what type of data it would hold, and giving it a name. Think of it as reserving a labeled box in memory where you can store a value. And here is a syntax. In Java, every variable must have a type which tells the computer what kind of data it will hold. You cannot declare a variable like b equal to 10 or name equals to Peter, right? Because you need to specify a data type for each variable. And in the right side of the slide, you can see the correct syntax. And in this example, it only has declaration. We don't assign a value yet. You need to specify a data type for each variable. If we know that our variable need to store an integer, we can declare it in this format. And for a text, there is a specific data type string. So the variable will be declared in this format, string name. So the syntax is data type and variable name. And data type here, it defines the type of data the variable will hold, for example, integer, double, string, etc. And variable name is the name you give to the variable, for example, age, score, name, etc. When you declare a variable without assigning any values, Java reserves memory for this data type, but this variable doesn't have a value yet. Alright, let's talk about variable declaration with initialization. You can also declare and assign a value at the same time. For example, integer age equals to 31, string name equals to Mikita. Now the variable not only exists, but already stores a value, and this is usually recommended because it prevents errors from using uninitialized variables. Now let's open our IntelliJ IDEA and create new package and class for this lesson. As you're already aware, to create the new package, we need to do the right click on Java, New, and Package. If you don't have your IntelliJ IDEA set up, please go back to the lesson number 1 and follow the procedure. Let's name this package lesson 2. And as per naming convention, we need to have all the package names as lowercase, then hit return or enter. So now we have an empty package, but we need to create a class. Let's do the right click on the package, new Java class. And for now, we can name it program1. And in this example, class supposed to be starting from the uppercase character. So for each class to run, we need to create the main method. And in the previous lesson, I described the different versions of the main method. Just because we're using JDK 25, we can use it in this format, static void main. But if you're using Java less than 21, you need to follow the standard approach. Just as an example, let me type the old version of the main method. Public static void main string. Then we need to add args. And again, right, this is the new version for JDK 21 plus. And this one is everything, which is less than JDK 21. Alright, so for now I'm gonna delete it, but keep in mind. Alright, so let's declare our first variables. Int age, for example, and then age equals to 31. In this line number 5, this is the declaration, variable declaration, and in line number 6, we're assigning the value. Alright, let's do the same with the string. String name equals to, and I'm gonna put my name, but please type yours. String name equals to Mikita. In this format, this is the declaration plus initialization in the same time. Now let's print it out. So again, by typing SOUT and pressing tab or return, which is enter, we can open this command. But please try to type it manually because you're beginners. You need to remember each and every word. So here I'm adding double quotes, name, I'm giving a space plus name variable. And the second one is age, empty space plus age. So what will be the output? Let's execute the program by clicking on this triangle right here, run program. As you can see, name Mikita, age 31. If the variable already declared without an assigned value, when we later assign this variable, we don't need to specify a data type anymore, right? Let's try this scenario, for example. So let's say we want to assign variable n, right? Integer n, for example, equals to 10, right? So to change value of this, we don't need to type int n equals to 11, right? The IntelliJ will throw an error. If we hover over, it says variable n is already defined in the scope. So IntelliJ will throw an error because we already have a variable with the name n, and the second line is considered as an attempt to declare a new variable with the same name. That's why we are seeing an error. To fix it, we need to delete int, right? And in this case, new variable n equals to 11, and let's try to print the value of n. Execute the program one more time. As you can see, the variable was reassigned properly to 11, and we see this output in the console. Please keep in mind that in Java, program logic is executed from top to bottom, line by line. So let's declare a new variable and assign a value. Let it be integer number equal to 21. Now let's create a command which will print this variable in the console. And then let's change it for number. It is going to be equal to 22, right? And the same command, number. Let me divide it. All right, so as you can see, we declared variable number and assigned it a value and created the comment which will print this value of this variable in the console. And then we changed this variable, reassigned the different value, and print it again. So what will happen? Let's run it. As you can see, first 21 was printed, which is from line 23 right here, right? Then value was changed and 22 was printed from this line. It happens because in Java, all the execution happens from top to bottom. Please keep in mind. Now let's talk about variable declaration approach. In Java, if you want to declare multiple variables of the same data type, there are a few approaches you can follow. Let's go through them clearly. So, approach number 1, declare a variable separately. As you can see, you can declare each variable on its own line, like integer age, integer score, integer level. Simple and clear, but it takes more lines. It is useful if you want to initialize later individually. If every variable has a different data type, we can only declare them using this way. Now we have a second approach, declare variables together in one line. And you can declare multiple variables of the same type in a single line by separating them with commas. As you can see, integer age, comma, score, comma, level. And it saves place. And I have one important note here. All variables should have the same data type. Only then you can combine multiple variables while declaring. And you can also initialize while declaring. As you can see, int age equals to 25, comma, scope equal to 100, comma, level equals to 1. Let's try both approaches in our IntelliJ. Let's create another Java class. Do the right click on package, new, Java class. And let's name it program 2. Again, we need a main method. So by typing main and hit tab, it will open for you static void main parentheses. And you don't need to type it manually. But again, I recommend you to do it manually. So let's try both approaches in our IntelliJ. Approach number 1, int age. Don't forget that each line in your logic should have semicolon in the end. Then integer score, semicolon, int level, semicolon. I mean, this is pretty straightforward, but you need to type more and it takes more space. It was the approach number 1. Approach 1. And let's try the different approach, approach 2. And here, we just need to type it in this format. Int x equals to 5. Then we need to hit comma. Y equals to 10. And for example, z equals to 15 and semicolon in the end. So both works fine, as you can see. And keep in mind that in both approaches, we can assign values right away or just declare a variable. So let's recap. Declaration reserves more memory but doesn't always assign a value. Initialization assigns a value to the variable. You can declare first and assign later or do both at the same time. It's up to you. Variables must be declared before use, otherwise Java will give an error. And what does it mean? For example, we want to use variable number, right? And we're trying to print some number. As you can see, it doesn't exist, right? We need to declare this variable first. Int number equals to 100. And then we can use it. So declare first and then use it. Alright, now let's talk about variables naming convention. And we already discussed some naming conventions for class, method, and package in the previous video. Let's now discuss some best practices for variables naming conventions. Variable must start with the letter, $, or underscore, and it cannot start with a number. It cannot contain spaces. You cannot use Java keywords like class or int as the name of the variable. Try to use meaningful names. For example, age, username, total score. So every person who reads your code can understand. So here I have a couple examples of good and bad names for variables. And as you can see, good variable names are total score and username, and bad are x, a1b, and int, right? So you can understand why they are bad. All right, let's go back to IntelliJ. Right, let me create program 3, new, Java class, program 3, main. All right, so variables are not fixed. You can update them anytime in your program. Um, for example, integer age equals to 25, then age equals to 26. As you can see here on line number 6, value changed from 25 to 26. So think of variables as storage boxes with labels. Always choose clear names so your code is easy to read. Practice by creating variables of different types and printing them with the system out, println. Okay, so we already have integer age. Let's create string with the name. And again, I will put my name, but you please put yours. Then let's create another type of variable, which is boolean. Please type with me. And let's name it is Java fun. And as you can see, I'm using the camel case where it starts with the lowercase letter, and every next word it starts with uppercase. And boolean has only true or false kind of values. Let's assign the value true. So let's print all of this value into the console. And the first one starts with the double quotes, name, and let's add our names. So this is the format where we need to have this. Then the second line, age, and then add age here. And this is not my age, this is just an example. Then the last one is Java fun? And we need to add is Java fun. As you can see, I'm started typing this variable name, and IntelliJ provides me options. In this case, only one option. I just need to hit return to add it. And let's see the output. Run the program. And as you can see, name, age, and is Java fun. We see these values in output data. All right, now let's talk about Java data types. And Java data types are mainly divided into two categories. Primitive data types, it's basic building blocks of Java, and non-primitive data types, which is reference, like objects, arrays, classes, and string. Today, as we're only starting our Java path, we're focusing on the primitive data types. We will cover non-primitive data types in further sessions. So there are 8 primitive data types in Java. As you can see, first column is a data type name. The second column is size. This is description and example. Let's really quick go through them one by one. So byte contains only one byte. It needed to store small integers. And here's an example, byte age 25. For short, the size can be 2 bytes, and it stores medium integers from and to. Values are here. Here's an example of the short variable. Int is 4 bytes. It stores standard integers from and to. As you can see, int scores equals to 100. For long is again for integers, but large in integers. It has 8 bytes, and here is the example. As you can see, we need to add uppercase letter L in the end. So float is 4 bytes. It stores decimal numbers with less precision. Here is an example of float, and we need to add F in the end. For double, it stores decimal numbers with higher precision. So as you can see, double salary, we have a number and then dot and then 2 decimal numbers. Char, only 2 bytes, and it stores a single character. As you can see, char grade equals to A. In this case, we're not using double quotes as in a string. In this case, we're using single quotes. And boolean, 1 bit only. It stores true or false. As you can see, boolean is Java fun equals to true. So let's open IntelliJ IDEA and practice with primitive types. Let's create a new one, new Java class, program 4, main. Let's just declare all of them and assign values first, and then we'll discuss one by one. So let's start from byte. Age equals to 25. Let's do the real age. Byte age equals to 31. Short distance equals to 3000, for example. Then score, for example, equals to 100. Then long, population, it could be 78. L, it's just a random number. Then float, price equals to, then double, for example, something like this. Character equals to A, and equal to true. So something like this. Let's print each and every variable's value separately. So we have 1, 2, 3, 4, 5, 6, 7, 8, right? 8 types. And let's do system out. Let's do this way. And do the 8 times. So let's type, for example, first age, right? Then do the plus age. And this is called concatenation. We'll go through it a little later. Then we have distance. Then we have score. And as you can see, another advantage of using the IDEs, right? Before we created any variables, they have the gray color. It means that this variable was never used. As you can see, variable score is never used. But we called those first 2 variables, and they become white because they were used somewhere. So let's see how the variable name score changes after we type its name. score. See, it's white. Okay, so after score we have population. Plus population. Then we have price. Then we have salary. Then there is grade. Then is Java fun? Is Java fun? Alright, if you need more time, please pause this video. But if you're done, then you can click on execution and run the program. As you can see, we have this output, which has the text and values for each and every variable. And as you can see, we have first 4 are for integers, different type of integers like numbers, right? Then we have 2 for decimals. Then 1 is a char, which is one single character, and true or false condition. So let's go one by one. First thing I want to mention is that, as you can see, we have this long data type, and it has uppercase letter L. Let's discuss it. By default, integer literals like 100, 5000 are considered as int in Java. If you want a number to be treated as a long, you need to add this uppercase L at the end. And this tells Java the number is too big for an int. Treat it as long, right? As you can see, this is the regular int and this is the long. Without L, it will not work. Let's try to create one variable. Population 2 equals to, let's copy the same number. And as you can see, it throws an error. Integer number too large, right? But when we add L, it works. You can use uppercase L or lowercase l, but uppercase L is recommended because lowercase l can look like the number 1. As you can see, if we change it to L, it can look like 1. So let's not confuse ourselves. Even IntelliJ throws not an error, but it will recommend to replace lowercase l with uppercase L. So let's delete it anyway. Now let's discuss float. As you can see, float price equal to 1999F. And by default, decimal literals like 314 or in this case 1999 are considered as double in Java, like this, right? 45,000.75. If you want a number to be a float, you need to add F at the end, like we see in this case. So this tells Java, store this decimal as a float, not as a double. We can do another example. Double D equals to 314. Float F equals to 3.14 F. As you can see, here is the syntax. And let's try to delete F. And as you can see, IntelliJ throws an error, right? It says required type float, but provided double. And as a one part of the solution, we can convert literal to float. But here we just need to simply type letter F. And why this happens? Int and double are Java defaults for integer and decimal literals, and Java wants to prevent accidental data loss. Int is the smallest than long, and float is less precise than double. So you must explicitly tell Java when you want a larger integer, long, or less precise decimal float. Always specify when the literal's type is different from the default. This prevents data loss and compile time errors. So now let's talk about char. What is char in Java? The char data type is used to store a single character. Let me give you some examples. It could be a letter, like, for example, A, or uh, uppercase or lowercase letter. And then it could be a digit, like 1 or 9. What else? It could be a symbol. In this case, for example, a dollar sign, or like at symbol. Then it could be even a white space, just an empty space. And char cannot store multiple characters or numbers directly. Even one is treated as a character, not as a number, right? And we cannot put bb, or like it cannot contain more than one character. Two and more are not allowed completely. It doesn't matter. It's a letter, digit, symbol, or white space. Not allowed. And you can see the syntax, right? Char grade equals to A. A needs to be in the single quotes. So single quotes are mandatory for char literals because double quotes are used for a string. And string is a sequence of characters. As you can see, we have another data type, right? String name equals to Makita. We're not talking about this data type for now because for now we are only focusing on primitive data types, and string is not primitive data type. As you can see, it even has a different color, right? Boolean is a kind of the orange, and string is white. So string is a sequence of characters. We need to see the difference between regular character and sequence of character, which is a string. So for now, let's just see this difference. And let me delete it. Also, char uses 16 bits, which is 2 bytes of memory. It stores a Unicode character, which means it can represent 65,500 different characters. And just because we've touched char data type, I need to mention a very important thing, an ASCII table. So what is the ASCII table? ASCII stands for American Standard Code for Information Interchange. It is a standard that assigns a unique number for each character. Computers use numbers, so ASCII allows computers to represent letters, digits, symbols, and control characters as numbers. Think of ASCII as a dictionary that maps characters to numbers. How ASCII works? Let's open the website. We can simply turn ASCII table, and let's check the ASCIIcode.com. This is the website. Let's scroll down a little bit. So each character has a decimal number from 0 to 27. As you can see, this is the 0, and here is a symbol. So we can scroll down to number 65, and 65 is the first letter symbol. In Java, the char data type stores a character, and each character has a numeric unique code, unique value. So the first 128 Unicode characters matches the ASCII table exactly. So you can convert a char to an integer to see the ASCII value. So let's go back to the IntelliJ. Let's create a new program. Program 5 main. So let's declare a couple variables. Char letter equals to uppercase A, then char digit equals to 5, char symbol equals to @ sign, and let's print all of them. Let's do the double quotes. And then plus, then letter, plus, equals to integer letter. So don't worry about this part. I will go through this logic later. Let's just copy it, paste 2 times, and second one is digit, and the third one is symbol. All right, let's save and execute them. And as you can see, ASCII value of this letter A equals to 65, right? Let's open this 65. As you can see, uppercase A. For ASCII of 5, it's 53. Let's see. 53 is number 5, as you can see this row, right? So this is the decimal number, and here is the symbol itself. And let's check the last one. ASCII of @ is 64. 64 here, as you can see. Yes, everything matches properly. Why ASCII is important? For text storage, right? Computers store text as numbers. And for the comparison as well, you can compare characters using ASCII values. For example, let's go back to IntelliJ. Like if A is greater than B, then system out print lane A comes before B. So we will go through this logic a little later. Let's just change it for now. Let's execute it. And as a result, as you can see, A comes before B. So also we can convert characters to numbers and vice versa. And ASCII is also used in different protocols like HTTP, email, and files. Here are a couple points to remember. ASCII maps characters to numbers, 0 to 127 standard. Char in Java is stored as the Unicode value, which includes ASCII values. It is useful for text processing, comparison, and encoding. All right, now let's talk about boolean. As you can see in our previous program number 4, we do have boolean, right? Is Java fun? True, right? It also can contain false. So 2 type of value it can hold. Let's turn back to true because Java is fun. So let's delete everything what we have here and discuss Boolean data type in Java. So Boolean is a primitive data type that stores only 2 possible values, true and false, right? It is mainly used to represent logical conditions or decisions in your program. Think of it as an off and on switch, either yes or no, right? On and off, like yes or no switch. And let me write a couple examples. Boolean is Java fun we already have. Let's do is raining equals to false. So where booleans are used? Booleans are used primarily in different conditions, like if statements. We will go through this topic later. In different loops. like for loop, for each loop, while loop, etc., and with logical operators like and, or, and not. And again, so all of these topics will be covered later in this course. Let's talk about size and storage. So conceptually, a boolean needs only one bit because it's like a true or false, right? In Java, the JVM, which is Java Virtual Machine, may use a full byte, which is 8 bits, for alignment and memory efficiency. So key points to remember. Boolean can only store true or false, nothing else. It is widely used in decision making and logic operations. It helps control programs flow with conditions and loops. It works with logical operators and, or, and not. Alright, now let's take a quick look at non-primitive data types in Java. But as I said, more detailed lecture for this topic will be covered later. Our goal here is to go step by step and not be overwhelmed with complex information right away. So make sure to subscribe to the channel so you don't miss any new Java sessions. Alright, so non-primitive reference data types. This includes strings, arrays, objects, classes, and interfaces. They store references like addresses in memory rather than actual data. Keep in mind that all the primitive data types start with lowercase character and non-primitive data types with uppercase letter. So for now, we will focus on string only. What is a string? A string in Java is a sequence of characters. It can hold letters, numbers, symbols, or spaces. Strings are objects in Java, not primitive data types. Strings are immutable, which means once you create a string, you cannot change its value. If you modify it, a new string object is created. Here is the example of the string declaration. String name equals to Mikita, and the system out println name. In this format, we can print out this value in the console. So why strings are important? Using strings, we can store text like names, messages, passwords, or sentences. A string can be manipulated with built-in methods to check lengths, convert case, split, etc. This is an essential thing for user input, file handling, and web applications. Let's go back to IntelliJ and create new program. Program number 6. Main method. Right, let's declare a string name. Please provide your name. And string greeting, which is equals to hello world. Let's do the comma here. All right, it was first way to declare string. And let me show you the second way. We can declare a string using a new keyword. So string city equals to new string and the actual value, New York. String city equals to new string New York. As you can see, we have the comment from IntelliJ. If we hover over, it says new string is redundant. So we don't have to use the new keyword. It's better to declare variable and assign value in this format. But there is also an option to declare variable in this format. So let's summarize. Primitive data types, they are simple, fixed size, and they don't have methods. Non-primitive data types, they are flexible, can call methods, store objects or arrays, like string, array, class, etc. And we are focusing on int, double, char, boolean, and string because these are used most often. Again, right, from primitive data type, we use primarily int, double, boolean, and from non-primitive data types, we're primarily using strings. These are used most often. Now let's talk about the concatenation. What is concatenation in Java? Concatenation means joining or combining two or more strings together. In Java, we use it to connect text and variables into one readable message. Think of it like sticking two strings of text together to make one longer string. So how to concatenate strings? As you can see, we need to use plus operator. This is the most common and easiest way to combine strings. We will try this example in our IntelliJ in a minute, but just keep in mind, right? So we declared first variable string, assign the value a second variable, assign the value as well, and in the string full name, we perform the concatenation using the plus sign. So let's go to our IntelliJ. Yeah, let's create the new program, new Java class, program 7, hit enter, main method, string first name equals to, and again, right, I will type mine, please type your name here, then string last name, and then we need to have a string full name. So how to perform the concatenation, right? We already have two previous variables. Let's type it in this format. First name, then plus, then, but what will happen if we're just gonna print this variable values, full name, right? Let's hit print. Let's hit run. And as you can see, it gives the output in this format, right? Makita Kanota, which is my first and last name, and there is no space in between. How can we add the space, right? As we know, the space is kind of a part of the string, so we need to add it in this format. Space. But now we can see that this right part is giving us an error because we need to perform concatenation from the right side as well. So we need to have plus here and plus here. Let's run one more time. And as you can see, we have a space in between, which is our expected behavior. So you can also mix text and variables. For example, int age equals to 31, and then so my age is, and then concatenation with the age variable. Hit run. As you can see, we have the second line printed properly. So there are more ways to perform a concatenation of two strings, but they are out of scope for now. So they are by using concat method. Let me just type it here in comments so you will have an idea. Concat. This is the method. Also, there is a string dot format method, also string builder, and string buffer can help us with that. But for now, just keep in mind that there are other ways to perform concatenation. So to recap, concatenation is joining strings together. You can use plus, concat, string.format, or string builder, string buffer to perform concatenations. You can concatenate strings with numbers, booleans, or variables. Java automatically converts them to text. So now let's say we have three int variables and we want to print all values in one statement. So let's create them. Integer a equals to 10, then integer b equals to 20, integer c equals to 30, right? And our goal is to just print them one by one. So can we do it in this way? What will happen? A plus B plus C. What do you think happens? Will it print 10, 20, 30 in one line without spaces? Let's take a look. No, as you can see, it printed number 60, right? Because this command will perform an arithmetical operation and print the summary of three variables. So for concatenation to happen, there should be at least one string data type. For example, we can do it in this format. Like even if we add empty string here, as you can see, empty string plus a plus b plus c, and then run. Before it was 60. Let's take a look what's going to happen now. Now it's 10, 20, 30, right? It was like one option. Also, we can delete this and create a new variable, string d equals to empty space. If we add this variable, string d, in the very beginning, it will perform the concatenation. Also, we can delete this and insert our string somewhere in between. Like this, make spaces. As you can see, 10, 20, 30, and we have spaces in between. Let's see another example. Let's type this. Let me create a new program for this, maybe. Program 8. Main int ends score equals to 9. And then int John's score equals to 10. And let's try to print this. Ends score is plus n score. And let's do the same for the John score. John's score is plus John's score. And now in the third line, let's print the total score, right? Let's type total score is, and now we need to perform the arithmetical operation here, right? Hence, score plus John's score, right? But what will happen? So n score is 9, John's score is 10. What will be printed here? Will it be printed 19 or not? Let me run the program. And as you can see, it's printed n score is 9, John's score is 10, but total score is 9, 10, right? So it just performed the concatenation but didn't do any arithmetical operation. And we know it happens because in the very beginning we have the string data type, right? So it starts with a string and then everything else will be concatenated as string as well. So in order, if we want to count, we need to add parentheses. So first, this mathematical expression happens, then it will be concatenated with the string. Let's execute. As you can see, total score is 19, which is our expected behavior. So what happened, right? It performed a sum operation first, then concatenated with the string. And again, if you have any questions or if something was not clear for you, feel free to leave a comment below. I'll be happy to explain it further. In Java, primitive data types are the most basic building blocks of data storage. So they are called primitive because they are not objects. They represent simply values directly stored in memory. Think of them as the raw ingredients of a Java program. Everything else is built on top of them. So how do they work? When you create a variable with a primitive data type, Java reserves a specific amount of memory for that variable. The value is stored directly in that memory location, not as a reference or object. Each primitive type has a fixed size and default value. Let's take a look on the table. So as you can see, this table contains primitive data types and is pretty similar with one that we saw earlier, right? But here, the main difference is that we can see minimum value and maximum value for each and every data type. As you can see for byte, for example, the minimum value is minus 128, and for maximum value is 127. And we have examples for each and every value. So you can pause here and check minimum and maximum values for byte, short, int, long, float, double, char, and boolean, and check examples as well. So why Java uses primitive types? For example, for performance, primitive types are faster because they store data directly in memory. For simplicity, they are easy to use for basic arithmetic or logic. For memory efficiency as well, each type uses a fixed small amount of memory. For example, int uses 4 bytes, no matter how many times you use it in your code. So here are the key takeaways. Java has 8 primitive types, the simplest data representations. They are stored by value, not by reference. Each type has a fixed memory size, making Java memory efficient. You will use primitive constantly for numbers, characters, and logic. They are the foundation of all other data types and classes in Java. So, why do we need non primitive data types in Java? Primitive data types like int, double, and boolean are great for storing simple single values. But what if we want to work with words, lists of data, or real world objects like a car, person, or a student record? That's where non primitive data types come in. Number one, to store complex or multiple values. Primitive types can only hold one value at a time. If you want to store multiple values or represent something more complex, you need non primitive data types like string to store a sequence of characters, text, array to store a group of values of the same type, class or object to represent a real-world entity, to represent real-world entities with multiple attributes. Number two, to use built-in methods. Primitive data types don't have methods. You cannot do like h.uppercase or score.length. Non-primitive types are objects, so they come with built-in methods that make your work easier. We will cover these methods a little later during this course. Number three, to model real-world entities. In real-world applications, we often deal with complex data structures like students, employees, bank accounts, or cars. Primitive types alone are not enough to represent them. So we create classes, a type of non-primitive data that combine multiple variables and behaviors. Number four, to enable code reuse and modularity. Non-primitive types like classes, arrays, and objects make your code more organized, reusable, and scalable. You can define your own data types, custom classes, and reuse them across different parts of a program. Number 5. To handle dynamic and large data. Primitive types are fixed in size and simple. For large and dynamic data like user input, files, databases, or web data, we use non-primitive types. For example, string for text data, array list for dynamic list, hash map for key value pairs, like class for object representing complex entities, and so on. In short, we need non-primitive data types because they let us store, organize, and manipulate complex data. They support methods for easier processing. They allow object-oriented programming. They make our programs more flexible and powerful. So let's summarize primitive versus non-primitive data types. As you can see, um, feature-wise, primitive, single simple value. Non-primitive, complex, or multiple values. In terms of size, primitive fixed, non-primitive can vary. In terms of methods, primitive don't have methods, non-primitive have built-in methods. Here are some examples. Int, double, boolean, non-primitive string, array, class, object. This is just some of the examples, not all of them. And usage, right? A primitive we use for simple tasks or storing the data. and non-primitive, real-world, and complex applications. So, how to decide which primitive data type to use? When you're choosing a primitive type, think about what kind of value you need to store and how big or precise it needs to be, right? Let's go through it step by step. So number one, what kind of data do you need to store? For whole numbers without decimals, use int, long, short, or byte. For decimal numbers, use float or double. For single character, you're gonna use char. For true or false values, use boolean. How large can the number be? If you need to store small numbers, for example, number of students, let's use int. For very large numbers, for example, population, distances, or even the phone number, you can use long. For tiny numbers, like file size in bytes, etc., you can use byte or short. So number three, do you need decimals? If you need numbers with fractions, you will use either float or double. Use float when memory is limited or less precision is fine. Use double when you need accuracy, for example, prices, measurements, etc. Number four, are you working with single symbols or letter? Then use char. If you hold a single character like A1 or hash, you can use char data type. And number five, are you checking for conditions? When you want to store true or false values, use boolean. For example, boolean is Java fun equals to true, or boolean is raining equals to false. And here is the rule of thumb how to decide which primitive data types to use. You can stop the recording and analyze this table. And here are some tips for your knowledge. Int is the most common for whole numbers. Double is the most common for decimal numbers. Always add uppercase L for long values and lowercase f for float values. Choose the smallest data type that fits your need to save memory, right? So for memory efficiency. Boolean and char are for logic and characters, not for numbers. Now I want to discuss one very important topic, constant in Java. So what is constant? A constant is a named memory location whose value cannot change once it assigned. In Java, constants are created using the final keyword. Value is fixed after initialization. It cannot be reassigned, typically written with uppercase letters as a naming convention. And here is a syntax. Final, then data type, constant name, and value. What is the difference between final and regular variable in terms of syntax, right? The keyword final is there, plus the variable name is in uppercase. And instead of using the camel case, we're using the uppercase letters and underscore in between words. And here is an example. Final double pi equals to 3.14, right? So this variable will not be changed, right? Because this number will be always like this. We don't need to change it. Final int max users equals to 100. It can be the constant variable because we know that our maximum number of users will be 100 and not more than that. So we don't need to change it later. So we can declare this variable as final. Think of a constant as a permanent label that you cannot override. And here is a comparison between variable and constant. You can pause this video to analyze this table, but it's pretty straightforward. So in summary, use variables when you need flexible change in data and use constants when you need fixed values that should never change, like pi, max limits, configuration values. And just for demonstration purposes, let me open IntelliJ. And here in the program number 8, we can create a couple more constant variables. Let me declare them. Final, double, pi, as you can see, it is uppercase equals to 3.14159, semicolon. Then final int max users equals to 100. So now let's print both values in the console. And okay, let's execute the program. As you can see, PI is always 3.14. Max user's value is always 100. So this is the way how can we declare the final or constant variable in Java. All right, that wraps up our discussion on variables and data type in Java. I hope now you have a clear understanding of int, float, char, boolean, string, and other types, and when to use each one of them in your programs. Also, if you're interested in learning software testing and automation, check out my book on Amazon, Software Testing Unlocked, a beginner's guide to QA and automation. It's a 20-step journey from a beginner to your first QA job. It's a complete roadmap designed to help you start a real career in QA and automation testing. If you found this video helpful, make sure to hit the like button, subscribe, and turn on notifications so you don't miss the upcoming videos in this Java for Beginners series. Thanks for watching. This is GNT Creator. I will see you in the next video. Bye.